Okay, we were doing sequences and I told you that I'll share another formula. For example, we had this last question. The sequence was 3, 9, 17 and 27. One of the method is right in front of you on right hand side, an square plus bn plus c, where a is half of second difference, which was 2, and half of 2 is 1. So n square plus bn plus c, then c was the 0th term. So we went reverse and we found the 0th term is -1, and then we chose 27, which was the 4th term, to find the formula, which resulted as n square plus 3n minus 1. Now I'm copying the same sequence and solving it with the different method. Sequence is 3, 9, 17 and 27. 3, 9, 17 and 27. First of all, you have to check that if it is quadratic sequence or not. So the difference is 6, then 8, then 10. This difference is 2, this is again 2. So yes, it is quadratic sequence. Now what is the second method? So this is a plus n minus 1 into d. You remember this was for the linear sequence, but the change is plus d by 2 into n minus 1 into n minus 2. Now check this. I'm placing 1 over here and 2 over here. This is d1 and d2. A is the first term, which is 3 already, plus n minus 1, and d is this first difference, 6, plus d2. d2 is this second difference. So 2 by 2, n minus 1 into n minus 2. So what are we plugging in? We are getting a from the sequence, we are getting d1 from the sequence, and we are getting d2 from the sequence. Everything else is general form of n. So we keep on simplifying. This is 3 plus 6n minus 6. 2 by 2 is 1. N into n is n square minus 2n minus n plus 2. So finally n square, 6 minus 2 minus 3 is plus 3n. 3 minus 6 is minus 3 plus 2 is minus 1. So n square plus 3n minus 1, and which was n square plus 3n minus 1. So in the second method, you don't have to think about anything. Just plug in these correct values and solve it. Let's try this again. 1, 6, 15, 28. 1, 6, 15, 28. 5, 9, 13. And then we have 4 and 4. So it is quadratic sequence. Formula: a plus n minus 1 into d1 plus d2 by 2 into n minus 1 into n minus 2. So a is the first term, 1 plus n minus 1, and d is this 5, first difference, and d2 is this 4. 4 by 2, n minus 1, n minus 2. Now we just simplify. So this is 1 plus 5n minus 5 plus 2 into n square minus 2n minus n plus 2. 1 plus 5n minus 5 n square minus 3n plus 2. 1 minus 5 is minus 4 plus 5n plus 2n square minus 6n plus 4, and 2n square. 5n minus 6n is minus n. 2n square minus n. So this is your formula. 2n square minus n, and 2n square minus n. Clear? Any questions? Okay. Now next is cubic and exponential sequences. Now there's no general formula. We just have to think through the sequence. Exercise 1.4D, question number 1. This is 1, 8, 27, 64. Find the formula for the nth term. So what do you think this sequence is? Sometimes it's easy if you have the term numbers with you. This is the first term, this is second, this is third, this is fourth. So what's happening to the term numbers, and we are getting these results. RS, any guesses? N cube, that's right. 1 cube is 1, 2 cube is 8, 3 cube is 27, and 4 cube is 64. So sequence is N cubed. Question number 2. 2, 4, 8, 16. 2 raised to the power n. You mean this? That's right. So 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, and 2 power 4 is 16. Question number 3. 1, 3, 9, 27. And meanwhile, when will we get our results? Sorry, when is the result for the test? 10th. So what do you think about the sequence 1, 3, 9, 27? First of all, do you think this is something related to the digit 3? Like 3, 9, 27? So it could have been simply 3 raised to power n, but 3 raised to power 1 is 3 minus 1, that's right. So anything power 0 is 1, then when you plug in 2 you get 3, plug in 3, that is 3 square, so you get 9 and so on. Is any confusion? 13, 20, 39, 76. I'll need your help. I do not have my calculator with me today. So 13, 20, 39, 76. What do you think is happening here? If we just check the difference, that is 7, then 19, this is 37, this is cubic something. I don't think this is helping us. So let's try to compare. 1, 12 more, 8, 12 more, 27, 12 more. Look at the first sequence. Can you see them both in the screen? this one right here and this one. Look at both of these. If I compare both of these, every term is 12 more than the first question. One plus 12 is 13, 8 plus 12 is 20, 27 plus 12 is 39, and 64 plus 12 is 76. So this sequence is n cube plus 12. Question number 5. 6, 18, 54, 162. Check if all of these are divisible by 6. So this is 6 times 1, this is 6 times 3, 54 divided by 6 is 9, 6 times 9, and 162 divided by 6 is 27. So again we can think about 1, 3, 9 and 27, which is in question number 3. So this is 3 raised to power n minus 1, and every term is multiplying with 6. Let's compare with this term. 1, 3, 9, 27. So 1, 3, 9, 27. This was 3 raised to power something. So in order to get 1, we had to write 3 raised to power n minus 1. Question number 6. Minus 4, 3, 22, and 59. Any guesses? Hint is this is n cube something. Okay, if we just write n cube. Now for first term we need to write 1, right? N cube is 1, but we have minus 4. So what should I change here to get minus 4? What do I do to get minus 4? I'm getting 1. Minus 5. So if we try minus 5, we get minus 4. My formula should be n cube minus 5. Now I have to check if this is correct. So I'm checking with the second term. N cube minus 5. 2 cube minus 5 is 8 minus 5, which is 3. So finally it is n cube minus 5. Question number 7. 9, 11, 15, 23. Okay, if we try 2 raised to power n, Got this? Okay, if we make this guess, this is plus 7. But if we check for the second one, 2 raised power n plus 7, if we check for the second one, this is actually 2 raised power 2, that is 4 plus 7, which is 11, yes. And to be sure, third one again, 2n plus 7, 3 is 2 cube is 8 plus 7, 15. So yes, 2 raised to the power n plus 7. Question 8. 2, 10, 30, 68. Hmm. Eight, 20, 38. If I just try 2 raised power n, 1 would be yes, 2 raised to power 2, I have to add something, so that's a no. And if we try cube, n cube, 1 cube is 1 plus 1, 2 cube is 8 plus 2, 3 cube is 27 plus 3. So we are adding 1, then 2, then 3. So I'm trying n cube plus n. You see how I reached this point? I just tried n cube. So when we try 1, I'm getting 1, I had to get 2. So I can see that if I add 1, I'll get my answer. For the second one, same attempt, 2 cube plus 1, this is 8, but I can see that I had to add 2, not 1. So I had to add 2. Third one is 3 cube is 27, then I had to add 3. So this 1, then 2, then 3. So basically this is equal to the term number. So n cube plus n. Checking for the fourth number is 4 cube plus 4, 64 plus 4 is 68. So n cube plus n is the correct formula for the sequence. Try question number 9. Zero, 4, 18, 48. Any guesses? Please say that again. Okay, let's try this. N cube minus n square. So this is 1 cube minus 1 squared which is 0. Or the second one, this is 2 cube minus 2 square is 8 minus 4 is 4. And the third one is 3 cube minus 3 square. 27 minus 9 is 18. Oh, very good. I didn't thought that. And last one is 4 cube minus 4 squared. 64 minus 16 is 48. Excellent. So n cube minus n square. Last one. Question number 10. 3, 12, 35 and 80. If I try 3 raised to power something, you're saying n cube plus 2n. So this is 1 cube is 1 plus 2, 3. 2 cube is 8 plus 4 is 12. And 3 cube is 27 plus 6 is 35. Very good. N cube plus 2n. This leads us to our next topic, approximation and estimation.